Let's get started. So, hey everyone, great to be here. We heard a lot about MQTT and Sparkplug and unified namespace today. What I want to talk about here is about real-world case studies and architectures for both MQTT and Apache Kafka. So the goal is really to show you a lot of different use cases from the real world so that you see how these technologies are very different from each other and still very complementary. So you will see use cases for only MQTT, you will see use cases for only Kafka, and you will see several use cases and architectures where both are combined, and very often also even joint customers from HiveMQ and Confluent. That's the main idea of the next 30 minutes, so I hope it's helpful so that you see a broad spectrum of things you can do. And with that, let's get started. So here's the agenda. First, I will talk a little bit about MQTT versus Kafka. And versus here doesn't mean that they are fighting with each other, but really to understand the differences of the two technologies. There's a lot of misconceptions very often that I will clarify. And then really I walk you through very different use cases, manufacturing, connected vehicles, mobility services, smart city, where obviously both MQTT and Kafka are a perfect fit for some specific things and not for others. And that's in the end what I will talk about in the next 30 minutes. So first of all, let's talk about MQTT and Kafka. And in the end, when I talk about Kafka or more general in data streaming, then I really see a lot of misconceptions in the market here. Sometimes it's intentional also from some vendors because they only want to talk about a few pieces from a technology because they want to sell other products. But therefore, I really want to start clarifying what Kafka actually is. So who in the room uses or knows Kafka? So I think it's something like 30–40%, right? And I can tell you, I mean, I work for Confluent, right? So we do Kafka and stream processing. Now we also added Flink to the stack. But in the end, I can tell you that even in our customer base, many people that use Kafka, they don't really know what you can do with it. So let's get started with a short definition so that we have the same understanding about everything what Kafka is. So Kafka has 4 different pillars of capabilities on a very high level. Number 1, it's a real-time message broker. So that's what most people know, and that's what they also then often compare to MQTT brokers. So real-time messaging in the end, however, is already 2 things here. So Kafka was built for extreme scale from the beginning. So we have customers in Confluent Cloud that process 10 GB and more per second with a single Kafka cluster. So this is pretty good for many use cases. And on the other side, however, and this is what people already underestimate, most of our customers use Kafka also for transactional data. So this is really payments, orders, and similar scenarios, where it's really about 0 data loss and transactional behavior. So this is number 1, messaging. Number 2, and this is already the fundamental difference to other message brokers, and no matter if you talk about MQTT for IoT or something like RabbitMQ or IBM in the IT space. So Kafka is an event store. And this is why I always use this picture to explain what Kafka is, because you see the events flowing in. And in contrary to a message broker, where the only goal is to deliver them as soon as possible to the consumers with PubSub. In addition to that, the event store of Kafka stores them as long as you want. And this is huge, because with this capability, you can really build decoupled applications in very different business units, like in the IoT business unit or in the operational technology with SCADA systems. And on the other side, maybe with analytics or maybe with customer-facing applications. So Kafka truly decouples the system from each other. You get the event in once, and then it's stored for hours maybe for log data or sensor data, or maybe for months or years for customer data or payments. In the meantime, Kafka also enhanced its capabilities using tiered storage. So most people call this more cloud native. It separates compute from storage. And with that, you also can store terabytes or even petabytes in Kafka, and some customers do that, to replay historical data whenever you want that. Right? And so the combination of real-time messaging at any scale with the persistence layer to truly decouple systems. This is why Kafka more or less became the de facto standard for microservices, because you need to decouple independent applications and technologies. Now, this is number 1, messaging, number 2, storage in an event store. Number 3 is the data integration part. So messaging alone, well, for some use cases it's great, right? And we know that from the MQTT use cases. But for many other IT scenarios, you need to do data integration with other databases, with file-based systems, with data lakes, with data warehouses, with applications. So Kafka brings Kafka Connect, which is an integration layer on the Kafka principle, Scalable, real-time, guaranteed ordering, and all these things are built into the integration layer. So you don't need to use an additional ETL tool to your favorite message broker. In addition to that, number 4 is stream processing. We've heard about that a little bit today already. So this is about correlation of data in real time in the right context. This is a fundamental paradigm shift from just storing data in yet another database or data lake to process it later. Because if you think about your business, and it doesn't matter what you're doing, think about that. Real-time data beats slow data. So as soon as you can act, you should act on data. Like in the industrial space for condition monitoring and predictive maintenance. But also more like after-sales scenarios for recommendations for upselling. And this is really what Kafka is. So it's much more than just a message broker. And this is important to understand if we talk about the joint stories of MQTT and Kafka in most projects. So if we think about the trade-offs, and really more specifically now versus MQTT, right, to understand when to use which technology. As I just explained, so Kafka is much more than the message broker. That's the pros in the end, as you see here in green specifically then. And on the red side, the cons, well, it's super easy to qualify out when not to use Kafka, especially in the IoT space. So it's not built for tens of thousands or even millions of connections. It's simply not possible in a technical way to do Kafka with that. It's not possible. It's that easy. It usually requires a stable network, otherwise you are in trouble. It's that easy. And it also doesn't have IoT-specific features because that was never the goal of Kafka, right? And with these kind of definitions, it's really easy to understand when to use Kafka and even more easy to understand when to not use it. On the other side, MQTT, I mean, I don't need to do an intro here, right? I guess almost everyone in the room knows it better than I do. Therefore, let's directly go onto the trade-offs. And again, specifically looking at that, comparing it with Kafka. And therefore, MQTT is perfect for building thousands of connections. It's perfect for poor connectivity and high latency scenarios in the networks. Exactly what Kafka cannot do. However, MQTT is a message broker. In contrary to a streaming platform, the goal of it is PubSub. It produces messages from sensors or other systems. You store it in the broker and then you push it to your consumers. Can be one or more, but that's in the end the goal of an MQTT broker. And that's it, right? And so it's perfect purpose for some use cases, but not so good for some others where you need to do more things, which are not IoT specific. And this is really why in the market we see so many use cases where MQTT and Kafka are combined. Because they're really a match made in heaven because they have so different sweet spots. They have some overlappings. Both of them are real-time messaging. And if you use the right technology, then MQTT scales well too. But this is really how it fits together perfectly. And with that understanding now, we can talk about very different use cases and examples. Let's start with manufacturing. And again, so this is in the end a deck I built together with the CTO of HiveMQ a few quarters ago. So this includes case studies from both HiveMQ and Confluent. But in the same way, of course, you can think about that from the open source perspective with MQTT implementations and open source Kafka. So the first, I always have 2 examples, right, in each section. So the first one here for manufacturing is from Daimler, where they do automotive manufacturing. In the end, it's about a vehicle diagnostic system. And here are a few interesting characteristics, right? The first bullet point says, critical part of manufacturing. This is exactly a use case which shouldn't go down, because a downtime in manufacturing of an hour typically costs tens of thousands of dollars or more. So it's super critical. And on the other side, if you take a look at what was implemented here, it's about 10,000 testing devices that are connected, that produce millions of messages. So on the one side, you need the scale, which MQTT provides with the right implementation under the hood. And on the other side, you need to connect to all these different devices. So that's something which Kafka never could do directly. And this is where MQTT is a perfect use case to solve such a problem, like here what Daimler does in manufacturing. On the other side now, if we take a look at a Kafka use case, and therefore here we have an example from BMW, and this might now surprise some people actually, but this is a case study about connecting smart factories to the cloud. So in this scenario, and BMW has so many projects, right? Some are only MQTT, some are only Kafka, some others are both together. In this use case, however, this is only a Kafka use case. This is not MQTT. So in this case, the shop floor, like the robotic systems and PLCs, directly connect to Confluent Cloud, so the fully managed Kafka, and from there the data is shared with different information systems. The first use case was visibility, know what's going on in the factory, creating a simple dashboard, but that's huge value already. Second use case then was more like correlating the data with other systems from SAP, from the ERP system. So you get high volume of sensor data, you correlate and pre-process it with the streaming platform, and then you connect the right information with the SAP system to take action on that. And then the third use case, and you see where it's going, right? It's more and more use cases that are using the same data from very different business units and technologies. And then the third use case was about after sales. So it was not about the manufacturing team anymore. In this case now it was about a sales and marketing team. They now combine the data from the factories to provide better value to their customers. And here, really, the short story is that in the end, you get the data out of the OT world once, in this case, directly to Confluent Cloud, and then you use it in many other systems. This is a sweet spot of Kafka. It decouples systems, and you can consume the data with your own API or technology in your own pace. Real-time batch request response, it doesn't matter, because it's in the event store, and then you consume it when you need it with your own API and technology. And so you see very different use cases, one from Daimler and one from BMW. In this case, there was no need for MQTT because it was a direct connection. So this use case is on Azure Cloud. And so BMW works together with Azure, and they have a stable connection from the factory to the cloud. The safety critical workloads do not run in the cloud. It has to run at the edge, right? But for these kind of use cases, where it's not safety critical, this can be done completely in the cloud because cloud has a lot of benefits for these use cases. And here's one example of an architecture. So for each section, I have a different architecture, so that you see there's so many flexibility and deployment options for that. Like in this case, where we deploy HiveMQ as MQTT broker and Confluent for streaming at the edge in the factory, which got much easier in the meantime for Kafka since it has no zookeeper anymore and runs in Docker and in Kubernetes and so on. And also to the question from the panel before, right? How do you connect other systems to that? Well, I'm not so sure if you really should integrate SAP ERP directly with an MQTT broker, right? I don't see the value of that, right? Because it's data that's more on the business object side that correlates with other data. And you need an integration platform because if you have tried to connect an SAP ECC to MQTT, well, good luck. It's proprietary. It uses BAPI and IDOCs, right? That's not MQTT. For an MES, it might look different, like in this picture, because that may be it's much more production system, right? So down to manufacturing. So that might have better integration in MQTT. But you are flexible. You can turn this around how it makes sense for your architecture. Now, next is connected vehicles. And I would say, if you need to find one specific use case where only MQTT works, then that's it. So we as Confluent, we also work with many OEMs, right? But the last mile integration to the connected vehicles, I have not seen a use case I can remember where it's not MQTT because it's so perfect, because it can connect to millions of devices with the right MQTT implementation under the hood, of course, like HiveMQ. And on the other side, then you connect these millions of devices, and then you need to do something with the data. And in this case, like this is an example from Autonomic, which is in the end a transportation mobility cloud service. So they're connecting to millions of cars via MQTT, bad networks, millions of connections. And then they transmit it and integrate it into Kafka, and there the further processing of the data happens. This can be pre-processing of data, correlation of data, plenty of use cases you can implement step by step. The flow in many companies is very similar. First, you start with visibility, know what's going on, building a dashboard. Then building a second use case, a third, a fourth. Then it gets more complex and advanced very often. But here's a perfect example for a connected vehicle software that connects to millions of cars or vehicles with HiveMQ. And now on the other side, and this is an extreme other example, this is from my Porsche. So, and again, each of these OEMs, right, they have so many projects, this is just one of them. And here you see Porsche even has built their own streaming logo, so they call it Streamzilla, which they use, which I find pretty cool. And in the end, for this use case here, this is more about the customer-facing information. So they need data from their CRM system, they need data from the order management system, They also need data from the shop floor level, which they get indirectly somehow, probably via proxy like MQTT or something else, I don't even know. But here now what they have built is in the end an omni-channel customer experience. So here, the different sales and marketing teams, they build their own applications, whatever they want to do. What they get with Kafka is in the end, out of the box, the decoupling of the systems. So you can build your own application without needing to know what the others are doing and what technologies they're using, it doesn't matter. You connect to the event or to more events, consume the data and build your applications like a mobile app or anything else. And if some of you work more in the OEM space with automotive, right, you might realize how hard it is for automotive companies to build omni-channel applications, like in this picture where you can either access information from your mobile app or from your laptop, or when you go to a store and want to talk to a human. Each of them has very different interfaces, and at these big organizations, these are very different technologies. Building such an omni-channel platform so that each of these systems has the right information at the right time, in a consistent way, this is a super hard problem if you don't use Kafka. So let's think about that again. You get information in, right, when I'm on the website and I am configure a car. And then I choose the color red. And then 2 days later I talk to my girlfriend and change the color from red to blue, right? It's another system, but the information is sent back as an event. And then a day later I go to the retail store where I talk to someone, a salesperson, and I want to buy the car. Hopefully that person knows what I did in the past. Not just that the last selection was red, but also that before that I also had an option for blue. And with this information, they have the consistent information about what I did in the past. Not just the updated information, everything. They can correlate that so that they know what they recommend to me. Like, if they have, and this is very simplified of course, right? But if they have a red car to sell and a blue car, but in their inventory they have 1 red car and 10 blue cars. Guess what they want to sell me? They want to sell me the blue car. And therefore, and this is where the stream processing comes in, so while I'm walking into the store, the salesperson gets a notification in real time to his tablet and he sees, oh, this is Kai and XYZ, he has that much money probably and here's the likelihood for this and that. So for Kai, we recommend him the blue car, we give him a 30% discount. He can also buy the red one, but here he only gets 10% discount, right? But this is how data is correlated from many different information systems. Not all of them are real time, many are not actually. But as soon as you need the right information, you get it in the right context. And this is the power of data streaming. It's much, much more than just messaging. It's a combination of data integration, messaging and storage at its core, and then data correlation with stream processing. And here another architecture. So this is an example now where we use Kubernetes. I remember back in the time, right, 5 years ago or so, where everybody started to adopting Kubernetes, most people said, don't deploy Kafka on Kubernetes because it's a stateful system and it's not possible on Kubernetes. Today, everybody does it, right? We also heard this in other presentations. If you know how to do that or get the right tools or vendors for that, this is the way to go because it's elastic. And in a similar way for MQTT with the brokers. Or if you're in the cloud, like in our cloud service, which is a serverless offering, under the hood we also deployed with Kubernetes for many different advantages. Like we heard in another talk before, where it's about multi-cluster management in a hybrid way between private cloud and edge. In our cloud, it's a bit different, but we need to deploy across multiple clouds, on Azure, on Google, on Microsoft, and across regions. So we have one template in the end, and then we can roll this out via the control plane to all the data planes on different clouds on Kubernetes. Now, the next example is about mobility services. So here, once again, first is an example about MQTT. This is an example from ZF about enabling next generation of mobility, how they call it. This is a bit a marketing term, I guess, but in the end it's about these kind of things you see on the right side. So it's in the end intelligent vehicles. And if you think about that, this is something where MQTT again is perfect because you need to connect to the vehicles on the street or on the rails, whatever it is exactly. And in this use case, ZF implemented remote diagnostics for technical insight and management of the vehicle performance. And also about fleet management. So if you have one specific project like this, where you need to transmit the information in real time continuously, and then build dashboards or alerting systems, MQTT is perfect for that, right? On the other side now, if we need to do more with the data, Well, this is again where a message broker alone is not good enough. And here is a concrete example from FreeNow. So this is the former MyTaxi in Europe or Germany. But you can also try this. So you can search for any of your favorite mobility services worldwide. They're all built on Kafka, everyone. Uber, Lyft in the US, Grab in Asia, really you name it, it's built on Kafka. Why? Because almost all of these services have 3 requirements. They only work in real time, right? But not real time for a message broker, no. Real time for the right information in the right context. Like estimated time of arrival. Like routing to the next point. They need to be scalable, and they need to run 24/7. And these 3 characteristics together, that's what data streaming provides. And this concrete use case here is one example at one ride-hailing use case, like here at FreeNow, is the so-called surge factor. You might have realized this in the real world already. So last week I was in Las Vegas at reInvent, and I already arrived on Saturday and went to a football game on Sunday. And if you have been in Vegas before, so reInvent is on the one side of the strip, and 5 miles away is the stadium on the other side of the strip. So I went to the game, and afterwards I thought, well, let's take an Uber back to my hotel, right? I even know that a surge factor exists, so this means that Uber knows exactly in which location how much demand there is. Because they connect under the hood also to other external systems, like the calendar of the football games. So they know ahead of time that there is a football game, so there's much more demand in Las Vegas on the strip for a taxi at that time, no matter where you are on the strip. And this is bad news for you, but I thought, well, it's okay, right? Instead of $25, I pay $50. But guess what? The proposal was $150. Yeah, because they can do it, right? It's how much demand is there, and people will pay it. And now here it gets even more interesting. If you stand in Vegas like me, I'm not a tourist, right? Because Uber, I mean, the US is much more data-driven than Europe, right? But Uber knows exactly that I'm from Germany. So they know in the end, I need a taxi if I don't know how to go elsewhere, right? Because I have no idea how else to use a bus or something, because I'm a dumb tourist. So they can charge the $150 to me. In my case, I didn't pay it, so the likelihood was maybe 50%. I didn't pay, someone else will. I walked for an hour, right? Which was okay for me. However, now the interesting part, this is just a piece of the surge factor. If I had a colleague next to me who lives in Las Vegas, he sees a different price even if he stands next to me. Why is that? Because it's not just about the situation on the street with the taxis and the football game, it's about all the historical information about every person that you feed into that system to make the right calculation in the analytic model. And this is an extreme example, but this is how you can use stream processing across any kind of industry to make the right decision in the right context. And here again is another architecture for that, right? Together with MQTT, where you connect to the last mile, in this case for the cars of the taxis or something. And on the other side, however, again, just knowing where the taxis are and the drivers are doesn't help. You need to know what's going on in the back end. Like in this picture here, it's about the traffic jam. So in real time, when I'm getting into the taxi, you need to make a decision. How should the driver ride me somewhere? Actually, in Vegas, I'm there every year a few times, right? So in Vegas, it's really interesting because in the past, nobody used a taxi anymore. Why not? Because from the airport to the strip, it's only a few miles. It costs $20. So the taxi drivers didn't like that. So they always took the route around there where it was $40. So no, everybody used Uber, right? So because in Uber, you have no choice. You drive where the Uber system tells you, and Uber tells you the best way, the cost-efficient way for the customer. And now the regulated government in the US had to change this. So now the taxi has a fixed price in Vegas. But this shows how now, if you correlate the data the right way, what power you have about making the right decisions for whatever your use case is. For this example of the connected vehicles, together with HiveMQ, we built a demo. This is already 2 years old or so, but it's still really cool. So it's built on top of Kubernetes. And in the end, it was really just to demonstrate how easy it is to build a really scalable and elastic solution end-to-end for connected vehicles. So this is really an advanced use case. So it's not just a dumb pipeline. This is a use case where we connect a simulation with the HiveMQ tools to 100,000 cars. So it's not just a hello world, it's 100,000 connections. And we feed data in, and not just into a dashboard, but instead we also train a model with TensorFlow to make some predictions. So it's really about real-time model scoring and inference for 100,000 vehicles in this case. This could be the same for equipment in the industrial space. So this is, because it's that easy to do, right? This took us a few hours to build. And last, let's talk a bit more about smart city as another example. So here, in this case, it's about an example from Barrelix about a cloud-based traffic control systems. So once again, so this is a use case where MQTT is perfect because it's about monitoring of traffic signals. So in this case, the solution runs in the cloud. Why not, right? Because it doesn't really matter if you do the monitoring of traffic systems, if it's in this cloud or in that data center there, right? With MQTT, you transfer the data to the cloud in a reliable way, even if the networks are not good, between the traffic lights and the cloud. And with that, you can do monitoring and in the future, then also more advanced use cases. So a really cool use case because then you can do it more dynamically over time. And with that, you can get a better customer satisfaction or in the city, the citizens are more happy. So this is a perfect use case where MQTT connects to all these different devices in the city to build use cases on top of that. And on the other side, and this is my last example today, and this is really interesting, and this is maybe also where you might think about in the next break. This is an example. So when I was in Vegas last week, I had a presentation together with Dish Wireless, which is one of our customers. Dish Wireless has built a cloud-native 5G infrastructure. So they had the lucky situation in the US that they could start greenfield. So they used Open RAN and really open cloud-native with AWS and others. So they built a cloud-native 5G infrastructure that is available in 70% of the US already. And there's two interesting parts. So first of all, it's about the architecture of how this infrastructure is built. So here's a lot of telco systems and analytics tools and so on. The interesting part for this is, of course, the middle, right? You can't read this stuff, but in the middle, it says Dish Wireless Confluent. So this is the data hub between all these different infrastructure systems, high volume log data, other telco infrastructure, but then also the analytics applications, the transactional order management, and so on. All of that, Confluent is in the end the data hub, right? Or the data fabric or whatever you call that. Not all of these systems are real-time, no. But their heart is event-based and scalable in real-time, so that each system can connect and always has consistent data. But what's now more interesting is how Dish goes to market with that. Because in the US now, these are the use cases they want to sell. This is in the end also what you know from the MQTT space, right? Across these different industries about connected networks of networks, about connected fleets, or then specific things for manufacturing or retail. And this gets interesting now because if such a 5G infrastructure is available, in the end where enterprise customers can also do network slicing and buy critical SLAs where 5G guarantees a stable network, this is then also where you can rethink how to use MQTT in that space. Because you don't need it then for the bad networks because the network is stable and you get an SLA from the telco. But therefore, if you have the stable network, you can build much more sophisticated end-to-end real-time scenarios like smart traffic, for example, because you know you have the connectivity and the throughput, and then you can use MQTT and Kafka to build all these use cases much more easily on top of that. And therefore, the last architecture just shows also what was discussed today before. It's not just about a one-way data pipeline, right? From these devices into the cloud for monitoring. It's really bidirectional, so it's also for command and control, depending on what the security allows. You can deploy it where you want, in the cloud, in the data center, at the edge. Or in this example, you see, this is deployed on AWS Wavelength, which is in the end not the public cloud, but this is a 5G infrastructure from AWS. So it's relatively close to the city, for example. So they roll out Wavelength across the big cities in the US. And then you can build many low latency use cases where the last mile connection is MQTT in both directions. And then you feed it into a Kafka cluster where you do the stream processing and other integrations with other systems. And only the critical systems are running here because this is much more expensive than the public cloud. So in parallel to processing the critical workloads here, you also communicate with the cloud where you, for example, ingest the data into Snowflake from a Kafka cluster there. So this was now a 30-minute overview about many different use cases. So this was not technical, right? This was really high level. I hope you saw a few different interesting ideas about what you can do with both Kafka and MQTT and how they're really complementary. They have a few overlaps, but in the end, they solve very different problems. And that's why many of our customers, and I think similar for HiveMQ, combine Kafka and MQTT for many use cases they build. Thanks a lot. Yep.
Yeah, we're going to take
Do we have time for questions? Or? Yeah.
Thank you, Kai. My name is Gaurav. I'm with HiveMQ. So you heard about unified namespace, and I know Confluent, and you also have spoken quite a bit about this. There is this concept called data mesh, which also you have spoken to. Is there a correlation there between data mesh and UNS, plus anything here for MQTT practitioners which can help make that connection?
So that's a great question, right? I thought before if I also discuss with the panel and ask a few questions, because in the end, and we discussed this over lunch here, unfortunately, actually, it's different things, right? Reality is there is not a unified namespace for everything. So UNS in this case, this is around the MQTT and IoT space where it makes total sense. In the data streaming world, like you typically use something like a schema registry and define contracts with that. If you go to a data lake, to a Databricks or Snowflake, you use something like Apache Iceberg or similar tools. So everyone has their own with their own sweet spots, right? Because the problems are different. With MQTT, you define hierarchies. That's something you cannot do in a Kafka topic. And you don't need it typically, right? And therefore, this is also why, and we have seen this in Mark's presentation, there are specific tools in the market that are emerging more and more, which are in the end a generic data catalog. So this is something like Microsoft Purview or Colibra, because then they integrate with all these different environments. So this is really, it's more or less each focus on their own domain because they have very different problems to solve. And overall, then this really builds the data mesh of very independent data products, how it's called there, where you choose your right technology. And then you combine them on the right level. But on the top, different things need different technologies and best practices. So a lot of things we discussed here, or this panel discussed, and Walker in the keynote, these are things which are not accurate in the same way for a streaming platform or data lake. And that's okay, right? Because it's very different problems. And so this is really the most important thing here, choose the right technology and best practices for each part. And in a similar discussion, should you connect your ERP system to MQTT? I'm not sure. For the MES, I think it makes much more sense. And obviously for the devices, absolutely, right? That's where you probably don't connect them directly to Kafka. We rarely do that.
Anyone else with a question? No questions.
Okay, thank you.
Right, so we've got